Example 1. Solve algebraically x cubed plus 2x squared is strictly less than 3x. So the first thing we have to do is make sure that we end our sentence in 0. So that means we want 0 on the right-hand side of the inequality. So subtracting 3x from both sides, we'll be solving x cubed plus 2x squared minus 3x is less than 0. So now we need to find the zeros of f of x. So we're going to do some factoring here. I see we have a common factor of x, so I'll get that out first. I'll have x squared plus 2x minus 3. I'll continue to factor that because I can. I'll have x plus 3 and x minus 1. So I have 3 zeros here. I have negative 3, 0, and 1. Now I'm going to use the zeros to divide the number line. Now this number line represents the x-axis, the domain values. So let's say negative 3 is about here. And let's say 0 is about here. And then 1 might be a little bit closer to 0 than negative 3 was. So I like to kind of dash a little boundary here. And I know that I have 3 zeros, so that means I have 4 sections. What I like to do is label them with letters. We have enough numbers here to deal with. So I have section A, section B, section C, and section D. I have 4 sections to use a test point to see what their signs are. So because we're solving for f of x is strictly less than 0, we want the negative regions. So now let's choose some points in all of these sections so that we can just see what the sign of the function is. So to the left of negative 3, I'll choose negative 4. So I need to find f of negative 4. So I have to do all of this math correctly. And if we write everything out first, and evaluated this, and you can use a calculator if you need to, but negative 4 cubed plus 2 times negative 4 squared minus 3 times negative 4 becomes negative 20. So this is negative. So is this a solution? Yes, it is. So I like to go back to section A and I like to say, well, this is a negative section. Now between negative 3 and 0, I can't use a boundary point. I have to use a number between. So what's a nice easy number in that region? Maybe negative 1. So I need to figure out what is f of negative 1. So I have negative 1 cubed plus 2 times negative 1 squared minus 3 times negative 1. And that equals positive 6. It's positive, it's not a solution. So back up to section B, I like to say that's a positive region. Now I need to pick a number between 0 and 1. I'm going to have to work with a fraction of 1/2. So what is f of 1/2? Well, it's 1/2 cubed plus 2 times 1/2 squared minus 3 times 1/2. And if you did all of this math, you would get this is negative 0.875. So it's negative, so it is a solution. So section C is negative. And finally, choose a number that's greater than 1. That's our last section to choose a test point. So I'll pick 2 because that's a nice number. So I'll have 2 cubed plus 2 times 2 squared minus 3 times 2. And if I do all that math correctly, I should get 10. And that is positive, so it is not a solution. So section D would be positive. Again, 3 zeros, so I have 4 sections. Now, shade the solution on the number line above. So I just like to say to myself, well, I have all of this on and on and on towards negative infinity, and I have between 0 and 1. So that's going to be parentheses. This is also going to be a parenthesis, and of course infinity or negative infinity is all parentheses. So I can write my solution. We're using parentheses as negative infinity to negative 3 union 0 to 1. Let me get that graph showing again if I can. There we go. So that's an interval notation, just read directly from the graph. So we can just jump to Desmos to sketch the graph here, but we could sketch the graph by putting in points and knowing that it's a polynomial and we don't have to lift the pencil, but let's just look at it quickly in Desmos. So I've already typed it in here, and it looks like a typical cubic curve, and it has a couple of turning points. I'll kind of get the gist of that sketch, and I'll bring it to our graph grid here. So we have negative 3 and positive 1 and 0. I have all of those zeros, and the graph will look something like this. It went way up and then it just dipped a little bit down and it kept going on forever. Well, we are looking for the negative solutions here. So we have below the graph here and we have below the graph here. So back to just a regular pen. What do we have? We're looking for everywhere below the x-axis. So the graph is below the x-axis from negative infinity to 3 and from 0 to 1. And so this agrees with what we did algebraically. So we could also say x is less than negative 3 and it is between 0 and 1.